Okay, so thanks everybody for coming. So today we've got Paul Harland from Snyk.
Hi.
Hi, Paul. So Paul is a channel solutions architect. So as he told me, he can correct me if I'm wrong, but that means that he's concerned with a lot of sales and pre-sales stuff at Snyk. So really, in terms of the partnership that we're trying to build with Snyk, this kind of means, and my understanding is, if we've got a client that has a problem that we think is, and I'm trying not to sound like the A-team now, but if we've got clients that think that their problems can be solved or helped with a tool like Snyk, and we need to put a solution in place, then somebody like Paul could come from Snyk to help us to implement that. So hopefully going forward, we'll have a lot more dealings with either with Paul or similar people at Snyk. So today, Paul is going to tell us about managing vulnerabilities with Snyk 101. So on you go, please, Paul. Thank you very much.
Excellent. I love it when a plan comes together. Okay, just by way of simple introduction, yep, Snyk is a cloud application security platform. Our strapline is help developers develop fast, stay secure. Quite a simple statement, but there's a lot involved in that, as you know, about the modern developer's role. Snyk actually is an acronym for So Now You Know. Not many people know that, but now you know. Okay, so let's just talk about the developer's role. In the cloud or pre-cloud era, developers were, yes, creating code and using open source code. But once that application was created, it was then perhaps given over to IT or ops, and they would make that live. They'd use things like Octopus deploy. They would push things to servers. And you know, they'd have an application and a web server, all those wonderful things that we used to do to get things live. As we moved over to the cloud native era, though, especially for people who use GitOps as part of their development strategy, they'd start noticing that containers would appear in that Git repository. Kubernetes clusters would appear in that Git repository. And first of all, it might be something that appears and they have to keep up to date. So now they've got a role of keeping containers up to date or adding new containers or pods into that Kubernetes cluster. So developers during that transition, which probably took a number of years or did, would start looking for tools that could help with each of those layers. So first, they'd be using SCA tools to look at what open source is in their repository and then how to fix that. Then they'd start saying, okay, we now need container security tools, and now we need configuration tools to help us with our Kubernetes configuration. This means they've probably got disparate tools that do this, or perhaps just two tools and they're missing one of those layers as well. So Snyk brings all that together into a single platform where you can look at all of those different layers. Now, to concentrate on open source first, why is it a big problem? Well, if we look at a modern application, a large percentage of that application comes from open source code, not the developer written code itself. And as we know, open source code gets developed by a disparate bunch of people around the world with different coding standards, kind of loose or not documented formally design structure to it, just an idea of what that package wants to do. That means there is going to be vulnerabilities of it. With open source, it's not a case of if there is going to be vulnerabilities, it's when and how many today. And according to Linus's rule, which is given enough eyeballs, every vulnerability is shallow. And that means that, look, we're going to expect vulnerabilities in open source code, but we're going to be able to fix them very quickly too. So knowing what versions you use, knowing what version you should use is very important to do. In the past, that was managed mainly by people, best endeavors. People who know about open source would check bulletin boards on a daily basis for new vulnerabilities, would keep Excel spreadsheets about what versions are used and what licenses they had. It's not a scalable solution, especially when applications are being given to lots of different teams now who make microservices rather than one big application. So we're seeing a huge drive both in the number of vulnerabilities per project and the number of projects being used per application being built. One great example of this is the Equifax hack. And if you can have a look, the attack or the exploit was first mentioned here on March the 7th. Now, that's when, if you were monitoring this with a piece of software, you would know about that problem. There's a number of ways you could then fix that. You could mitigate it by changing the package, updating the package, adding a front-end rule on a WAF in order to prevent that vulnerability. But then a few days later, attacks started. And then over on March the 22nd, when this was now a vulnerability that anyone could send robots out into the world to try and find, a huge spike in vulnerabilities actually happened. So the story here really is, you know, you're going to get vulnerabilities. You need a tool that can, at scale, monitor all of your code, that can tell you about all the vulnerabilities that are known, and that can show you how to fix them where possible as well. In this case, if you're using Snyk, you know, a few days after the fix was available, or the same day the fix was available, you can actually then go and fix it and prevent this attack a few days later. So the real thing there is, let's do it in an automated way, let's do it in a scalable way, and let's respond fast to any of those problems that are found. Bless you. So if we look at a modern application, again, I'm guessing in your projects, you're following the kind of GitOps structure where you'll get all of the layers of the application in a single repository. You're going to have your custom code, your open source code, your containers, and your infrastructure as code. As I said before, Snyk can cover all of those layers. So we can look using our SAST capability into the developer written code. Now, this is still very new for Snyk, but I can show you a quick preview of that today. The open source, which was our first proposition and where our database is really the largest and widest information out there, as I said before, makes up most of your project. And we can scan that in many different types of projects and let you know how to update it, not just in terms of the top level package, but in terms of vulnerabilities in transitive dependencies as well. And I'll show you an example of that in a minute. Containers as well, we look at the base images and the user instructions. We can tell you where the vulnerabilities are coming in, and again, build that full dependency tree, so then you can start doing things like container hardening. And then infrastructure as code, not specifically vulnerabilities, but misconfigurations. That's what we're looking for there. And we can scan the code, whether it's deployment YAMLs, Helm charts, or Terraform files. And that's going to be a growing list, by the way. And then we can measure those against a specific policy. Now, all of these tools are great, but if the security team has to use them, it's still not scalable. So at Snyk, what we've actually done is taken all that information and we've employed it in a DevSecOps way. Now, some people have different interpretations of what DevSecOps is. To us, it's an augmentation of the security compliance team by the development team. So we're not saying distribute all of the tasks of the security compliance team to everyone in the team. We're saying let's let the developers do some of that work. You're still going to need a dedicated security and compliance team because they have specialist knowledge and they have the knowledge of not just the application, but of the frameworks they need to adhere to and that release process after they think or know they've adhered to that. So we're saying let's create tools across that DevOps pipeline where developers can use the intelligence of Snyk to go and fix things. So in the IDEs on the command line interface, when the developers write in the code, we can scan there. The Git repositories, we can automatically scan and push pull requests out to Git repositories. In CI/CD, we can fail builds based on a certain profile of vulnerabilities or any vulnerabilities at all. And then over in live, the two most common are serverless functions and Kubernetes clusters. We can look at misconfigurations and vulnerabilities there as well. Underpinning all of that, and this is mainly used by that security compliance team, is the reporting suite that gives you that overall view of what's going on. So to state the last thing before we go into a little demo, it's all about empowering developers. That's the only way to scale. It's all about automating fixes if we can, therefore actually not having the devs have to switch focus. They can carry on working on what they're working on, and we're going to push those automatic fixes. But none of this will hold true if the database doesn't give false positives and gives all the real positives it can. So that security depth is ultimately very important. Any questions on what we've gone over so far before we go into a demonstration? Excellent. Okay, so as I go into my application now, you can see at the top, I'm on my container app and I'm in my dashboard. And that just gives me a quick overview of what's going on. So the automatic pull requests that we've created, the number of vulnerabilities and the number of license issues. But I'm a busy developer. I'm working on lots of different projects. So you can see here, I'm going to switch now to my web app. And I'm going to see the dashboard for that application or group of work. So here you can see we've got a different kind of report. Now, over into the projects, that was where I'd look at my individual scans. So these could be repos from the SCM tool. These could be container registry scans. They could be local scans from the machine, but they're all grouped into what is this logical project grouping. And this could be based on a business area, an actual application. And here you can see the number of vulnerabilities that we have. Customers generally go over to the integration section first. That's where we integrate with that DevOps pipeline. So source control, container registries, orchestrators, CI/CD tools, ID plugins. There's a lot there. We're not going to go through that today. What we are going to do is look at a scan, first of all, of open source. And here, what I'm going to do is add a project. One of my existing integrations comes up. I will click GitHub. Once I click GitHub, we go over there. We collect a list of repositories that my user can see. I'm going to select two projects, one a Goof project, which is Node.js, and one Java project, which is Java, and that's managed by Maven. I'm going to go and add those. So what we do then, we go over to, in this case, GitHub, but any SCM tool. We find the useful files to us. So the pom.xmls, the package JSONs, we're looking for Docker files, we're looking for deployment.yamls. And when we've actually done that scan, you'll see we create a report. Here's the Node.js one. That looks like this. So we've found three useful files that relate to the three different layers that we're looking at. As I say, I've not turned the code on here, but I will show you that in a minute. But as soon as that's fully live, you'll see all four layers there. We've got the package JSON, that's telling us about the vulnerabilities that are being brought in by the open source. Docker files tells us about the container, then deployment.yaml. Now, if I go into the package.json, this is again where Snyk differs. We don't want to just give people a big list of vulnerabilities. Nobody likes that. Everybody hides and puts those reports in the drawers. So what we do is try and give people the next best action. So here we've got a priority score which goes above and beyond high, medium, and low. Actually seeks things like, is a fix available? What's the CVSS score? What type of exploit is it? Is it mature? From that, we then push that to the top and we say, okay, Mr. or Mrs. Developer, this is the thing you need to fix first. And we're telling you where the problem exists and where it's fixed. And I can click that button and go and create a pull request. That will then appear in GitHub, and anyone who doesn't even use the Snyk UI will see that pull request appear. But I'm not going to fix that one actually. I'm going to just go into the dependency tree and have a bit more look around this project. Now you can see here at the top level, this is where vulnerabilities are being brought in by that top level package. But here, body parser itself doesn't have any vulnerabilities, but it asks for QS, a transitive dependency, and that does. So there are packages out there which would tell you QS has a problem. But at Snyk, we understand how to fix that problem in terms of the top level one. A particularly good example, if I look for MIME, you can see actually I have 1, 2, here we go, 3 vulnerabilities for MIME in my package. Now a developer, just given some information that MIME at 1.3.4 and 1.2.11 has a vulnerability, you need to go and fix it, might take a number of hours in order to understand the context of that report and then try and understand how to fix it. At Snyk, what we've done, we've turned that around, we've done that work for you. If I search for MIME, you can see we've grouped together those 3 vulnerable paths that end in MIME, 1.3.4 and 1.2.11. And if I go and fix this, we'll actually update the top level packages, Express and Tap. In fact, let's go and do it. First of all, I go to an interim screen. So you can see, let me show you the one. This is the one we've got selected to update MIME, but I can add more things into that pull request if I want. Generally, we don't want to do that. We want to keep our commits atomic so that we can roll them back if we need to without all that rebasey madness that you sometimes need to do. But then we can go and open a pull request. So we're going to update the package.json in this time, update the lock file as well, and we're going to create a nice commit message. That means that developers, as I said before, we don't actually want a vast majority of the developers using the Snyk platform. We just want to see them receiving the fixes into their Git repository and carry on working as they would. Only a few developers and a few of the security team would actually use the Snyk UI. So here you can see we've wrote a nice commit message. We can link to the vulnerability in our database, and the developers who are watching this repository will receive the notification from GitHub. But what we're also doing is testing that pull request as well. So here we're testing for license compliance and security issues. And it's got a tick. That means this pull request adds no new vulnerabilities in. But we're not just testing pull requests that we create. We're going to test every pull request by developers. So now you might have 3 or 4 feature branches going on, and them developers would then create a pull request, and Snyk would automatically say, actually, this pull request adds a new license policy violation or adds a new security issue. So that would be flagged to the repository maintainer. They'd understand and reject that work from the developer and let them know they need to fix that before they can merge back into master. So what we're doing there is giving you visibility of the vulnerabilities. We're allowing you to push in pull requests to fix them, but we're also now protecting that repository, making sure no new vulnerabilities can get added as well. And as an overview, that's really the description of that integration there on the Git repository. Now, if we're talking about even further shifting left, we want to start talking about the developer doing these tests on their local machine. And I apologize if I offend anyone here. I am a Windows user. I'm proud of it-ish. So on my local machine, if I want to test that, I could just do Snyk test. And one of the instances when I might want to do that, well, I might check out a new feature branch in order to do some work. So before I start work, I might want to see what my baseline is. I also might be adding a new open source piece of code. Therefore, I want to test it as I'm adding it as well. But you can see here, this is really interesting because what we do, we actually group these so the developer can see which upgrade will affect which vulnerabilities. And that just means that the developers are doing less and less work in order to fix multiple vulnerabilities. So that one change in my package.json will fix 7 different vulnerabilities. But what's also important is that we're letting people know about license issues as well. Now, I don't know if you do much to do with licenses when you're doing your code, or you leave that up to your clients who you're working with. But just briefly, licenses come in the copyleft or in the permissive realm. Copyleft means if you use this piece of code in your software, you in turn have to open source your software. Now, anyone who's building commercial software, you don't want them to do that because that just means that they have to open source. If they're building a banking piece of software, they don't want to have to open source it. So we want to make sure that in a commercial world, only permissive licenses are used. So in this case, we're actually looking at that repository and we're letting the developer know very early on about license issues. Now, licenses are checked anyway, you might say, at the compliance team later on. But at that point, the developer's already done the work. They've committed it. It's merged into master. The integration and unit tests have run. That has to go back to the developer to rework. So the earlier you can detect license issues, the better. So if I wanted to fix a license issue, however, that's a different story. We can't just update to a different version. We have to actually look for a different package. But Snyk will give you that information earlier, and then you can decide how to go about fixing that as well. We've also got integrations into the IDEs. I won't show you that today. What we'll do is actually a container scan. And if I switch back to a different project now, and I can show you what we can show developers about the containers. So here I'm integrating with Docker Hub. I'm looking at one container, but I'm looking at 2 different tags, first try and latest. Now, if I go into first try, the first thing you'll notice is we've got recommendations about the base image here. So we know the Docker file and we know the image. We piece them together, and then we can say your current image is based on Node 10.4, and that's got this risk profile here. If you could change to any of these, you would have these according risk profiles here. So it might just look like a small table, but if you were a developer trying to choose what the best base image is for your container and trying to keep that information up every single day, that could be quite onerous, quite a lot of work. So that table actually saves you time, plus it gives you the latest information every day. And to action that, I'd simply, in this case, go and copy that line, add that to the from at the top of my Docker file, rebuild, rescan, happy days. Again, what we're also doing though, is looking at the user instructions. Now, if I go and filter out anything from my base image here, I'm just looking at vulnerabilities that are brought in from user instructions. And here you can see, not only are we showing you the vulnerability, but we're showing you the line or the layer where that gets introduced. And there we can then decide, okay, do we need to use image magic? Why is that in there in the first place? Or we can use something different. So it's not as easy to know about which to update in terms of containers, but at least you know the vulnerability. Now, the next stage about containers, especially if you want to comply with CIS benchmarks, is about removing software that you don't need. So this is where, again, the dependency tree helps. You can understand the top level dependencies, but also lower down dependencies as well. Great example is curl here, not in itself vulnerable, but if I open that up, you can see the packages that it needs are vulnerable. So at this point, you can make a decision, actually, do I need curl on my live container? Can I just remove it or use a different base image that doesn't have it in the first place? And from this, you can then go and do some container hardening. And that is, you need to remove all software that you don't need anyway to be compatible with the CIS benchmark. Okay, so that roughly, again, is the container side of things. We're looking at the base image, the user instructions, we're giving you alternative base images, and we're also letting you see where the vulnerabilities from the user instruction. But the next thing is the containers need to go live. Now, in the past, that was a choice between Docker Swarm and Kubernetes. Not so much Docker Swarm these days. Do you generally use Kubernetes when you're working with customers? Anyone want to come off and give me a bit of info about that?
Before we move on, Paul, there's a question in the chat from
yes.
Pablo, which is, what is the flow Snyk has for trunk-based development projects which don't use pull requests? Can the license check be configured to discourage permissions licenses and encourage the use of copyleft ones such as the GPL?
Encourage the non-use of GPL, or well, it does encourage adherence to our policy, I guess.
Yeah, so I think the main part of that, there's kind of two questions there, isn't there? I think the first question is, what does it look like in a trunk-based development scenario where the pull requests are not part of the standard workflow?
Yeah, so if you're working on a different place, then obviously you're not creating the pull requests, or you're creating them on different branches. You can actually monitor different branches as well. You don't just have to monitor master. It's just we initially look at the default branch, whatever that is. So quite a lot of people as well have release branches or tagged release tags, and they want to start monitoring that, especially if they make embedded software. They'll need to monitor a version for the next 5 years out.
Yeah.
So we allow you to monitor lots of different branches. But we also allow scanning in different places as well. And that might be the best place to scan, as SCM is just one of them. So implementing the scan in the CI/CD tool might be the best place for you as well. And that's where we can monitor from that place as well.
Okay, so just to be clear, so if we're using trunk-based development, the general workflow of the developers is not to raise pull requests.
It's to merge in, yeah.
Yeah, so you're just going to be merging your stuff in. So in that circumstance, is Snyk still going to raise pull requests, or is it going to be acting as a sort of stopper? It's failing the builds.
So Snyk will raise a pull request on that branch.
Okay.
Okay. So we'll still monitor that branch. If we can see a fix, we'll raise a pull request. What we don't do though is scan developer pull requests, because they don't create them. But we can monitor those separate branches.
I see.
Yeah. So if I wanted, for instance, to go and scan a different repository, I'll just show you a quick.
I see. Yeah.
quick example here. I can go and choose that project, but I can go and say which branch that is. Oh, I've not got branch turned on here, sorry. But we do have a feature where we can choose a different branch. I think it's on my different web app. But also, yeah, as I say, what we can do is start doing the scans from CI/CD tools as well. So when it's being built, we can fail it, or they can do it on their local machine. And part of that really is the way Snyk works. So that's where I'd add my branch to monitor.
Okay, I see. Yeah.
Part of that is the way Snyk works. You know, we have all these integrations. We're not saying everybody should use them all. What we're saying is let's look at how you work and make sure that we're working with the actual customer on how to do it.
Okay, and I'm not sure I actually understand the second half of Pablo's question there.
Let me have a read.
Can the license check be configured to discourage permissive licenses and encourage the use of copyleft ones such as the GPL? So that sounds like
yes.
Oh, I see.
Absolutely. So let's cover that now. Actually, within the top level project is we understand. Yes, some people want copyleft, or they might want any license. It might be an internal project. So we allow you to create your own policies. What I showed you there was the Snyk default policy, which is anything copyleft high, anything with some copyleft characteristics more in the middle is medium, and all the permissives as none. But I can say, actually, for my internal policy, this is a project I'm making, my internal intranet, something I'm not releasing commercially. Actually, I can have any license. If you want to go one step further and deny the permissives, then you can go and find BSD here, for instance, or Apache, and say, actually, have them high. I don't want those in my project. So you can create your own policies as well. You just start with a Snyk default one, which is most useful to most customers. In a similar way, we can also do that with security policies. So it may be that actually Snyk's rating for certain CWEs is not what you want. You want to change that. So we also allow you to create different severities for different types of CWEs within that as well. So you can decide how important things are to you, or you can decide how things are not important as well. Hopefully that's answered the question.
I'll assume that Pablo will put another question in if that doesn't, but that sounded like
actually it was pretty well answered. Thank you.
Thank you very much. Okay, so I guess the next stage after imagine we've got our app clean, remove the vulnerabilities. We've done the same.
You did have a question before the questions came in. You asked us a question about what we use for containers.
Yes.
I don't use Kubernetes, but I do use Amazon ECS. So it's a similar, but it's just straight Docker containers running in their equivalent. So
yes. So in that sense, yeah, there's no kind of is that cloud formation script to send those live that you use?
No.
Or is it through the interface?
Kubernetes.
Right. Okay.
No, sorry, Terraform. We use Terraform to deploy it through out.
Right. Okay. So we do have Terraform monitoring that we can look for specific AWS things as well, which I could show you. So we look for things like EKS, the container repository as well in Amazon, and we can actually integrate directly with the Amazon environment as well, and starting to look at things like container drift from configuration as well. So there's new things being added there. In terms of Terraform, what we're mainly looking at is going live with Kubernetes clusters in AWS. But spreading that to Azure and Google Cloud as well. But we're also looking at that deployment.yaml side of things. I'll show you an example of that actually. Let's go and look at this live project here. When it loads. Need a bit of elevator music. So we've actually deployed the Snyk container on a live Kubernetes cluster. And this is where I'm going to find out that I've not got Docker Desktop running, isn't it? Oh, I have got Docker Desktop running. Fantastic. And what we're looking at here is two things. First of all, how is it set up? And we've added 5 tests it's failed out of the 6 tests we run in it. But we're also again looking at the containers that are live on that cluster. So we're seeing what vulnerabilities are on those live containers as well. And we do it there as well because people often send something live. It might be live for a month while development branches move forward. So we want to keep an eye on both of them and let the customer know whenever we find a vulnerability. But the first thing, we need to go and address these misconfigurations. So we go back to the Git repository where this deployment YAML was created. And it can either be Helm charts, deployment YAMLs, or Terraform, as I said. This one, it's actually a deployment.yaml. And what we do is we show you the file. And on the left-hand side, we show you the problems that we've found. Again, against a specific policy, which you can define. So for instance, here we're running without a memory limit. If I click on this one, we get an eyeball appearing where we should go and address this. It tells me the issue, the impact, and how it can be resolved. So I would go and add this line into my deployment.yaml along with a value, and then I could redeploy and get rid of that misconfiguration. Alternatively, if I didn't care about that rule, I would go up into the policies section for infrastructure as code, and I would decide, actually, I don't want to have memory even notified to me and turn that off. I'm not going to do it because it'll ruin my scan. But you can see what we've got here is either Kubernetes configuration, which looks at Helm charts and deployment YAMLs, and Terraform as well. So within Terraform, actually, Chris, let's see if we've got anything, any rules that look for things in your containers. So I think it's mainly looking at things to do with Azure Kubernetes clusters. But you can see we've got specific Azure and specific GCP rules as well.
I saw some ECS ones. You scroll past the ECS one above there.
ECS. Container insights disabled.
And there's one. There was a whole section of it further down, I'm sure.
Ah, was it? Right. Okay, let's go. I must have gone past it.
Hang on. I saw it. ACS. Right. Yeah.
Oh, ACS.
ECS.
ECS, right.
Sorry, I saw it. I saw it there. I just scrolled through something. It may have just been missing. Hang on.
I can't find it.
That's fine.
It's only finding one on my page when I'm doing the search.
That's it. I probably saw it as you scroll past. I just kind of.
Ah, right. Okay. There we go. But what we're doing here is we realize actually these policies are growing quite long. We need a better way to manage these. So we're working on that internally, looking at things like Open Policy Agent, which a lot of people use now, and how can we work with things like that as well. But overall, that is how a developer would use the platform, whether they want to use it on the local machine or the UI. On top of that, we've then got that view, which is the reports. So the security compliance team would see either all of their projects at once or some of their projects, even filter by type of ecosystem as well. How many vulnerabilities, how many license issues? Over time, what does that look like? And also, how quickly are we removing them once they've been found by the system as well? Ideally, you want to keep that under that 30 days because that's where we know attacks move from proof of concept to mature. We can then have a look at that top level issue as well. This is another really important one. So if I was working for Equifax and I saw that Apache struts problem all over the register in the morning, I might to come down and search for Apache struts here and see if we had that in any of our software. Then it would tell us if that vulnerability existed, but also which projects had it in and if it's fixable. And that's a great top-down view because you can start targeting the things you want to find, even order these by the Snyk priority score as well, and start targeting across the board which things you want to remove. So here I can see it's in 6 projects. It'll tell me which is fixable, which is not. The ones that are fixable, I'll speak to the tech lead on that project, get them to remove it, push out a new version. Where it's not fixable, the security team will decide what to do. Should we fix that in the front end? Should we remove the package entirely, use something else, or any number of ways to actually remove that problem as well. And then the last thing really is you also want to create reports, bill of materials reports for dependencies, licenses. We can allow you to do that as well. And I guess there's quite a lot of that in your role where you package and release software with your customers and want to actually create that bill of materials. This just allows you to do it in a very easy way. Nothing special, but also very important. Letting you see things like dependency health. You don't want to use an old dependency, even though it's the latest version. It just means it's not maintained well. And that's generally it for that kind of 101 view. You got any questions or things you'd like to ask about it?
I have a question.
Yes.
Yeah. So is it possible to install the Snyk UI and the database on premise?
So what we do have is 3 deployment methods. What I've showed you today is pure SaaS. We've then got something called brokered SaaS. So if a customer has on their own premises GitLab or Jira, we can deploy a broker which can mediate the communication between that on-premise environment and the Snyk SaaS service. That means they don't have to open their GitLab or Jira to the internet. The third option is then cloud native appliance, and that means we can deploy on a customer's virtual private AWS. Soon that will be rolled out to Azure and GCP as well. At the moment, that's just available on AWS, and that's their own single tenanted instance of Snyk, which we can actually reach dependent on how they want to set that up, but hosted on their own environment, yes.
Thank you.
What we don't do is traditional tin in a cold room in the office on-prem.
Yeah.
I think if there's any customer that wants that, they've got rather deeper problems than the problems that this tool should be addressing, to be fair.
I guess to provide just a little bit of context, it's for, I guess, quite regulated environments where, and what you're saying, obviously, yeah, obviously, if you want to put it on like a specific machine, they probably have a bigger problem, but it's sometimes hard to convince a customer that, yeah, so your answer is perfect. Thank you.
No problem, thank you.
I wanted to just ask a quick question, Paul, about something, and I preface my question by pointing out that I'm far from an expert in security. Right at the start, I think you said Linus's law. So are we talking about Linus Torvalds here?
Yes, Linus's law, yeah.
And you said every vulnerability is shallow.
Given enough eyes, yeah.
Yeah, what do we mean by a shallow vulnerability? Indulge my ignorance, I'm afraid.
It really comes from the whole ethos of open source development. So as you know, before Linus developed Git, developed Linux, and started working across the world creating open source, it was very much, and there's a great essay called the Cathedral and the Bazaar, which talks about this. It was very much a case of really designing software, a very close-knit team, building that software and only releasing it when it was perfect. And then the next release might be a year later. And this whole development kind of changed when Linus was starting to build Linux and needed to work across the world with distributed developers who had different coding styles and different ways of working. So they changed it into, let's just work with loosely defined goals. We want a piece of software that does this, not specific design. And let's release often. Yes, we're going to get bugs, but if we've got a big enough community, those bugs will be found very quickly and they'll be fixed. And that's what they mean by shallow. So you can always expect open source code to actually have vulnerabilities. And you can always expect more and more because the ecosystem's getting bigger. But you can, at the same time, expect that someone will find it quite quickly.
So presumably that means it will be exploited quite quickly, but also people will become aware of it and it becomes fixable quite quickly.
Yeah, but often if there's enough development, it will be found by the developer's eyes before it's fixed. Sometimes it's found by the user's eyes as well. The worst case is it's found when it's exploited. Yeah.
Okay. So moving on from, so there was another question, and again, excuse my ignorance. You showed us a timeline of the Equifax breach.
Yes.
And yeah, if you could just get that slide up again. I'm interested, so here, an exploit is made available through exploit DB. I'm not familiar with exploit DB, but from that caption, that sounds like a sort of criminal database of how to exploit stuff. The way that that's written, an exploit is made available. Does that not mean that if I look at exploit DB, I'm finding out how to exploit open source software? Is that right? Or have I missed?
Do you know what? You've actually just given me new context on that. I assumed, I've always assumed that was exploit DB is a place where you go to find vulnerabilities in order to be able to fix them. Well, right. Yes, absolutely. Criminals will use that in order to know how to attack a certain vulnerability.
Yeah, because it feels a bit, yeah, like I say, I'm not familiar. Perhaps somebody else on the call is more familiar than I am, but it sounds like a great resource to go out and build attacks, because you then said, see here, attacks begin immediately after the exploit is made available. So it does feel like, and then we see this peak on March the 22nd. So it took sort of 10 days for somebody to industrialize the process of the exploit and send some robots out there almost.
Yeah. That's the idea there, to work out how to find out if people were running that code, and then work out how to troll the net automatically on it.
And this period of time here from February the 14th to March the 6th, so that's 3 weeks-ish, 2.5 weeks.
Yeah.
Am I right in what's going on there is that the way that the dynamic of this works is that somebody is aware of the struts vulnerability, and the proper thing to do is to tell the people that are responsible for it, in this case Apache, and then it's up to them to fix it. But once they've fixed it, they then publish it, and that's what this means here, Apache releasing a fix. And at that point, it's kind of public, right? Because you've got to say what the vulnerability is to allow people the opportunity to fix it, I assume.
Yeah. So there's a responsible disclosure process.
Yeah.
So that's if you find a vulnerability, you try and speak to the package maintainer. You also try and help with the fix if you can, and you won't disclose it out in the wild until the package maintainer has got a fix or is not responsive, basically. And Snyk goes through that process quite a lot. So we find a lot of vulnerabilities using our systems and go through that either fix or disclosure process. But yeah, you want to give someone a chance to get a fix out there before you disclose it, then everyone can update as soon as possible.
Okay.
And it's only being able to monitor all of these things that happen in every day multiple times, they can make sure you get the latest.
And Chris Eyre has kindly shared to everybody in the chat the link to ExploitDB.
There we go.
I should probably have a look at that later, and I don't know if anybody else will as well. Okay, thanks for that. Does anybody else that isn't me have any questions for Paul at the moment? Sorry for taking over there. All gone a bit quiet.
Hi, I'll jump in with a quick one.
Yeah, thanks. Go ahead.
Yeah, so just to add that I likewise don't have strong security credentials, but I was wondering your categorization of severity of issues, is that something that you determine, or is that an industry standard? So what makes a vulnerability severe versus medium? So we've got lots and lots of vulnerabilities in these categories, presumably to help us prioritize. What is it that determines where a given vulnerability sits?
Yeah, no problem. And it is basically the CVSS score, which is a scoring system for vulnerabilities. Okay, and anything above 7 is high. Anything from 5 to 7 is medium. Below 5 is low. But we go further than that, and what we say is actually let's add extra.
Before you go on, CVS score, is that an industry-wide thing?
Yes, that is. That is a standard. I think there's a new version just out recently of it as well. But yeah, that's an industry standard.
Okay, thank you.
We've actually taken that severity one step further, and we've actually now started using this priority score, which also takes things into account. Actually, if it's fixable, should we add that higher up in the list? Because that means the developer can remove that right now. And is a mature exploit out there? So exploits can be, these 4 methods we've got. So no data is, we don't really understand how to exploit this, but it's kind of theoretical. No known exploit is, again, we've not seen it anywhere in the world. Proof of concept is someone's actually published a paper or a bit of information to show how to do this. And mature is it's rampant. Everyone's doing it.
Wow. So people publish POCs and say, there's this theoretical exploit, here's how you exploit it.
Yeah, absolutely. Yeah. And sometimes oh, sorry, go on.
Yeah, there's quite a lot of active research, isn't there, in the sort of security community around this, from what I understand. Is it also fair to say, Paul, that, and I'm sure I read this or heard this somewhere, that a majority of exploits or compromises in systems are typically ones where a fix has already been published and been available for some time. So it's people having basically stale dependencies for them. Yeah.
Yeah, absolutely. The vast majority out there have already got a fix. They've probably already got multiple fixes. People who don't take the practice of regularly scanning, therefore don't see the need to update dependencies unless it's got a new feature that they want. And that really, yeah, absolutely, because of how open source is created, there are going to be vulnerabilities. Maybe not go to the bleeding edge, which is something Snyk doesn't tell you to do. But let's go to a version where we know the fix is actually added. So yeah, you're absolutely right there.
Okay, thank you very much.
I've got another question coming in. You can do updates for, you can create pull requests for security vulnerabilities. Can it do for general other upgrades, or is it only the security dependencies?
Yes. So what we can do as well, we offered this option because there are some people who like to work this way. We can say, okay, actually, rather than just updating for vulnerabilities, let's actually update all of our dependencies to keep them up to the latest. And here we have two options. Let's just update to minor and major versions, or let's just update minor versions. As we know with semantic versioning, if you push that major version, you may have some code changes to do because the interface may change. So you want to set it between different things, perhaps. And we also add a choke on that to prevent developer noise. So you can have just one at a time being added in slowly over a time period, or you can add 5 a day being going there. But we also allow you to do that as well, yes.
Okay, I'm just trying to compare and contrast that to, say, Dependabot, which is a thing that specifically does that feature, and is again a lot better, a lot finer grained. It would be, again, it's one thing that is missing is a decent integration, because your two products don't play well together, is the best way of putting it.
Yeah, that's true. I mean, we do have an integration now into GitHub. One of the things I challenge people who use Dependabot, though, is how do they actually fix problems like that MIME problem I fixed previously. So if we look at this application, and I saw MIME appearing at 3 different places, we're creating a pull request here that will fix it in all of those places in one pull request. Now, over in Dependabot, they don't give you that context to say, actually, MIME is pulled in by Express. They'll just tell you that MIME is vulnerable at that version. And then the developer's got to work out how to go and fix it. So although it's the same information, albeit a different database, you're not getting the context on how to actually go and do that fix. And I think you can pull Snyk into the security solutions for GitHub as well now.
Yeah, we actually use it for, we actually use both. We use Snyk in the build pipeline for doing the security checks, and use Dependabot to keep everything up to date. Because if you put the two, if you both automate both of them, they will fight each other badly. And
yeah, have a little scrap over your
you have a little scrap, and you end up with releasing code that you never intended to release. So yeah, that's
yeah. So that might be something. I mean, what we have as well is the GitHub Actions, where you can start to do these tests. If we've released a lot of GitHub Actions for different types of projects, and that might be another place other than the build pipeline where you want to introduce that test. But yeah, certainly have one of those tools turned on, or at least screen your pull requests that get generated from that. Whichever one's the most useful to you at the time.
Yeah, I get the impression that GitHub wouldn't see it in its interest to make the integration between itself and Snyk smoother, because
it is fairly smooth once we start doing it. It's the Dependabot alerts are different though. Yeah, you can turn them on, but it's not just about security, as you were saying. I'm just trying to find that MIME problem here. So if I've got the MIME problem here, it'll tell me to go and update MIME in my dependencies, but MIME isn't a top level requirement of my project. So I can't do anything with that information. Whereas Snyk saying, actually, you've got a problem with MIME, but your top level dependency is, I couldn't remember which one it is Express and Tap. They're the things you need to update. So yeah, for different things. And like I say, Snyk's there for the security, but we also provide that let's update to the latest, either minor or major. Whereas Dependabot was let's update everything, and they've added security onto it. So coming from different places really, but we have converged, and I do take that point that you can see a little battle in the repository sometimes because of that.
Okay. Do we have any other questions, observations from everybody? Okay. I wanted to go back to a quick question. I'm interested, you mentioned, well, we just sort of skipped over it. There was a feature in there that was vulnerabilities in serverless.
Yes.
Is that, if I've understood that right, is that, I mean, how does that happen? Is that because your serverless code can just import JavaScript libraries in the same way that some Node code could or whatever?
Yeah, absolutely. Yeah. So we can integrate directly with AWS. We can look at all your requires in your Node application or however you're running your serverless, and we can look for the open source vulnerabilities in that. Yeah.
So that could be what, something like AWS Lambda that would just require some JavaScript library? Or does it work?
Yeah. So the two we work with are AWS Lambda and Azure as well.
Okay, right. So it is literally just that those your code that's running on that Lambda would pull in some dependencies.
Yeah. I mean, but often people usually have that code in the Git repository as well, so they can scan it there. So it appears in the Git repository and then gets packaged as a Lambda later and sent up.
Yeah.
So there's multiple places again where we scan those.
Yeah, that makes sense. Okay. I was pleased to see, just this is going out to everybody, that when Paul opened his PowerShell window, we didn't lose half the audience. So you know, I know that often that can cause people to go. It would have been interesting if you'd have opened Visual Studio or something like that. You never know. But,
I'll know for next time. Are we all Linux users here then?
Well, I was going to say, well, no, mainly Mac, but I'm sure there are some Linux users on the call.
Hey, I run PowerShell on my Mac anyway, so.
Yeah, I didn't notice any screams from the Vim lobby, so I'm not sure who represents the Vim lobby in our company.
We've got no Vim integration, no, sorry, or even Emacs, but maybe coming up.
Yeah, certainly not me that represents the Vim lobby, put it that way. Okay, so we've got a couple of minutes left. I mean, are there any more questions? Oh, there's an Arch Linux user there. That's Pablo saying he's an Arch Linux user and Vimmer. Oh, so Pablo's representing the Linux users and the Vim community. That's great. So maybe that's why, you know, maybe Pablo can start the Vim community.
Have you ever done Linux from scratch, though? That's the important question.
I have not yet.
Oh, well, there you go.
I did to install once in a virtual machine.
Well, we've comfortably gone beyond my competence and slightly away from the original topic. So I think as we're near the end of the time anyway, I'd just like to say thanks very much to Paul for coming. It's been a fascinating talk. I've got some notes and some things I want to go and check out. And just to reiterate to everybody that's still on the call, we do have a partnership with Snyk. These are common problems. I've seen them in every organization. You know, the partnership's there. If we feel like there are problems that could be solved or helped with this type of solution, then yeah, come and have a word with Snyk through, well, Natalie is our partnerships lead, so she's probably the first point of contact if we want to get anything going with Snyk. So thanks very much, everybody, for coming, and we'll see you all soon. And I'm going to stop.
Cheers.